I think I'm looking in the wrong direction. Okay, so I have my laptop below and my monitor above, and I tend to look at the monitor, so it looks like I'm looking into the horizon or something. Okay, don't worry, I'm very focused. Okay, so nice to see you all virtually, though I believe not everyone can turn on the video. So hopefully everybody's listening to this. Who is here? Good morning. Hello, Gajendra sir. Thank you for having me here. So okay, so it feels good to be here. I believe I keynoted the very first Belpai back in, was it 2012 or 2013, Gajendra sir?
It's 2015, sir.
20, oh, it was 2015. Okay. And I believe you're having it for the first time after that, right?
Yes, sir.
Okay. So all the best for that. I heard some very interesting, topics being mentioned by Mr. Karthik when I joined in here. Okay. So, after this, I'll probably try to hang on and listen to some of these topics. So all the best to speakers, attendees, and everyone. Okay. So about myself, probably it makes sense to just talk briefly about who I am and what I do, etc. So I came across Python in 2002. So yeah, yeah, Python was there in 2002. Okay, it was there even before that. So I've actually been working with Python, if you really look at it, for more than 18 years. Okay, so maybe, just maybe, one of the oldest Python programmers in the country. I hope so. Yeah, that also says something about my age, so you can try and guess at it. Definitely, I'm not going to tell what it is. Okay, so I have worked in different companies, different startups. And last like 7 8 years I've been working exclusively with startups. I love working with young engineers, kind of drawing from them and energy, learning from them, etc. I kind of started this group called Bank Papers back in 2005, and there is some articles you can read online about this. Recently one was published by FOSS United, so I'm not going to talk too much about it. I am a fellow of Python Software Foundation since 2010. And like I authored a book called Software Architecture with Python in 2017. Those are some highlights. Right now, I work for this startup called Zoco, which is a WhatsApp, which makes it easy for clients to use WhatsApp for their business workflows and for doing something we call as conversational e-commerce. I'm the architect, come engineering manager there. So we right now got selected for YC, Y Combinator in the winter batch. We are just in, so it's an exciting time for us there as well. So yeah, I think that's the background for me. Uh, Today, what I'm going to talk about is, Python is a very interesting language. Okay, it can seem like a very simple language to learn, but once you start with it and start, kind of getting yourself familiarized with it, like it is like this friend, or for those of you lucky to have girlfriends, guys, I'm saying, right? And it's like this friend or girlfriend who might surprise you, okay, suddenly, and in a very confusing wrong way, right? So this is a very light talk, actually. I believe in giving light talks early in the morning, so it's not a technically very heavy talk. I hope it will be an interesting talk. Okay, so probably some of you have seen these things, maybe many of you haven't seen. I hope it will be an exciting journey for the next 40-45 minutes. Okay, so on to me. If you're not able to hear me, or if you think I should look in the right direction or something, do let me know. I do have a problem with that because my laptop is below my monitor and I'm tending to look at the monitor. Okay, so maybe I can fix it now. Do you think my gaze is now better, right? Yeah, I'm looking at the monitor right now. So maybe I can present the whole thing inside the monitor today. Yes. So otherwise, I tend to look like somebody who's having squinty eyes or something. Huh? Okay, so things that may surprise you. I'm going to share my screen. I believe I still haven't done that. Just give me a second. Stop video. Share screen. Mhm. Okay, getting a bit confused with this. I think this is what I need. Can you see my screen or you can't?
We
Are you
can see,
seeing?
sir.
Are you seeing a slide which says Python things that may surprise you?
Yes, sir.
Okay, you are. Can I get an idea how many people are there online right now? Is it all the people I see or is it more?
It's 18, sir, right now.
So around how many people are there right now?
1-8, sir.
Can you say, could you say that again?
18, sir, 18.
18.
1-8.
Okay.
Yes, sir.
Okay, that's probably the
So
lowest attendance in my life. It's okay. I believe it's a virtual conference. Are you waiting for some VIPs to come in?
they may join, sir.
Okay,
We have sent the
cool.
link. Yeah.
Okay.
So India means a little bit
This is 18. So you
problem.
know what? I have
Yeah.
done classes, I have done trainings. I'm going to treat this as like a training thing, okay? Because
Yes, sir.
even you guys can also speak up. Can
Mm,
someone
mm.
say in the audience, say hi? Anyone? Or maybe all of you?
Hey, hi.
Hi.
This
Hi,
is
very good.
Sidhu
Okay.
from anybodycancode.in.
Yeah. So who are just one person I want to say, like, who thinks maybe he's the most experienced in Python here. So yeah, it's okay, so you know how much you have worked in Python, right? So if you think you have worked 3 or 4 years more than that, just tell me how many years you have worked so that I am sure if these are things that actually surprise you. Can someone turn the video on and just go ahead with it? It's okay. Whoever comes first. I like to make my talks interesting. So, someone, no one?
So Karthik here. So I worked for like 2 years now in Python. Uh,
Okay. By the way, I have no idea why I have kept this thing because there was no sound is coming through this. Okay, yeah, yeah. Go ahead.
so I have been working in Python from last 2 years. Not
2 years.
heavily working in Python because as a data engineer I work on lot of Spark Scala technologies as well. But then talking about machine learning models, definitely yes, Python.
Okay, machine learning. Yeah, yeah, yeah. I know, I know. So, yeah. So anybody who has worked more than 2 years, I'll make it very quick. We need to get on to the topic. Okay, so since nobody's turning up, I'll assume that it's less. Okay. So I'm going to, what do you call, lower your enthusiasm. I'm not going to talk about machine learning. I think there are enough talks about that. Okay. I'm going to talk about some things that may surprise you just with the core Python, just with the Python programming language. Okay. Sounds good? Fine. Cool. So,
Yes.
okay. So let's get on with that. I'm going to maximize this screen initially. Yeah. Gain F1, F11 should do that. Okay. So Python, as all these things, it's a free, libre, and open source language. FLOSS, whichever we want to say. If you like French people, you can say free and libre, FLOSS. Okay. If you have a problem with French, then say FLOSS. It's available under the liberal PSF license and current version stable release is 3.9.1, flexible and easy to learn, okay, etc., etc. Yeah, so let's start with something that I coded and I didn't want to type it down. So this is how the interpreter looks like. You guys all know that. And just to get the mood right, so I'm asking a question. Feels good that 2020 is over? Yes, and look at the options. Okay. Yeah, there are only two options. Yes and yes. Okay. So yeah. So if I actually code it, you know what's the right answer. Okay. So welcome 2021, right? Okay. So Python is an interesting language, but it can kind of surprise you, with its weird behavior sometimes. Okay, some gotchas or whatever you want to call it. So even at this time, right, this kind of behaviors have been persisting since Python 2.7, even at Python 3.9, or going to Python 4, you can still find this. Okay, so all these have been done on Python 3.9. I haven't yet upgraded to Python 3.9.1. So this is Python 3.9. So I'll try to show these things as I am typing. So how many people know this problem? How many people have seen this very famous? If you have taken the time to let's just explore Python a bit. Have you seen this? Okay, somebody's saying yes. So basically, if you can see my terminal here, right? Can you see my terminal?
Yes, sir.
Okay, good. So x is equal to 0.1, y is equal to, hopefully you can, it's big enough. Y is equal to 0.2, z is equal to 0.3, and you expect x plus y is equal to z. Actually false. Why? Plus y turns out to be 0.3, then a lot of zeros and a 4 at the end. Okay, so it's a very insignificant digit still. So this is basically what Python has an inbuilt representation error. Okay, for its floats. Not all languages have this because the actual value stored is the nearest representable binary fraction. You know how computers store it. I don't want to go through all that, right? So this is a very, this you don't get for all of the numbers. Okay, so if people have tried to kind of figure it out for other things. So if you do x equal to 0.3, y is equal to 0.4, x plus y, it's not really surprising you. X plus y is equal to 0.7. Okay, yeah. So it's not like a generic error, but you can see it in a few cases. Okay, so. And you can kind of see it when you do some multiplications as well. So maybe this is something which people have talked about. So 3 into x, sorry, x is equal to 0.1. Okay, 3 into x. Okay, so the problem is right there. Okay, it is not just because it is x plus y or anything like that. So x itself is having the problem. Okay, so x is 0.1, but internally it seems to be getting stored as something else. So we'll see how to expose this, in the next slide. Actually, so this what happens is that there's a slight variation, slight delta, because internally it is stored as binary fractions. So it's not exactly 0.1, it is actually 0.1, then something, some digits at the very end. So now the same problem happens with y also, 0.2 also. So you can actually see that if you say y is equal to 0.2, and then if you want to expose this problem, okay, you say 3 into y. Okay, right. And let's say 7 into y. Right. Let's say 9 into y. Oh, okay. That's fine. 5 into y. Okay. So at some times these things are getting exposed. What is it? Because there are some numbers when you multiply with this, this overflow happens, and this, it doesn't round off well enough. Okay. So you can try experimenting with it, but usually, odd numbers work basically. So not all of it every time, right? So yeah, so this is basically where we were. And so another thing is, like x equal to 0.1, and if you try 0.9 into x, what do you expect? 0.09, right? No. Again, that one is coming at the end. Okay, so you can expose it in multiple ways, and let's see what actually happens. When you so I'll skip this and I'll go to the next one. So what exactly is this, 0.1? What is it representing internally? And I don't know how many people have tried this. So it's very useful to do that. Can you see what I'm typing here? You can see my terminal, right? Hello?
Yes, sir. Yes, sir.
Okay.
Perfect, sir. No problem.
You should do this once in a while, guys. How many of you guys have played around with the decimal module? It's all machine. I know people you are using Python at a higher level nowadays, okay? So like I also do machine learning once in a while, but to me, these kind of things are interesting. Okay, so what is actually 0.1? 0.1 is 0.1. Someone with a quick eye, count how many zeros, looks like 12 zeros or something. See what is happening at the end. So a whole lot of insignificant digits are clouding it up, okay? And that when you round off, that 0.5 thing comes as 0.1, which is why 0.1 internally, when you do enough multiplication, it comes as 0.3000. Well, it's not 0.30004 like what we saw before. So there seems to be a discrepancy here. So I'll just show that again. A equal to 0.1, LB is equal to 0.2. A plus B is 0.3004. But when I'm doing, using the decimal, okay, it shows as, so I'll just show that again, 0.1, y is equal to 0.2, and let's do x plus y, 0.3000, Is it the same? No. Here it looks like it is. If you round off, it will become all that zeros and 2. But there it is 4. That is because there is a further representation error that happens on top of this. Okay. By the way, representation error is not an exception. Okay. So you try to say raise representation error, you're not going to get it. Don't get confused. Representation error is just a name. This doesn't work. There is no representation error. Just a name for the internal error in storing a fraction in the closest round of value. If you want to really know what fraction's true nature is, okay, use decimal module. If you want to get really like exact, you might want this for financial application. So there's a practical side to it actually, because financial application stocks, okay, like that 12th decimal, if you don't do it properly, it can probably cause a 1% difference in your annual, gross revenue. If you are a $1 billion company, correct? You know what I'm talking about? Huh? I think if people are using financial module, definitely tend to use a decimal module. Okay, so or libraries that tend to use a decimal module. You may not know that you're actually using a decimal module. Okay, how many people have used a decimal module here directly? You can just shout out. This is like a interactive thing. Okay, so hopefully I learned something here, right? Now let us go to something again a bit more weird in the same. So let me jump back to the previous thing, right? So you think that you can, do the same thing. I told that you can solve the problem by using decimal module or by rounding off. But rounding off also has some surprises. Okay, so x equal to 0.325. Round off x2. Rounding off x to 2 points. What do you think the value should be? 0.33, no? Correct? Okay, x equal to 0.375. Round x to 2 values, what should be the value be? 0.38. Good. Now x equal to 0.365. Round x to the nearest value. It refuses to round, okay? These are problems, okay? These are not, if you are a person who is, you're a banker, will be like, no, I'm not going to use Python because of this, right? So why does this happen? Again, decimal module comes to your help. So let's do decimal dot decimal. Find out what 0.325 actually is. That is why it rounds off, because 0.325 is 0.325 and then delta. So it is on the right side. Okay. 0.375. Wow. For some reason, Python is happy with 0.375. It's very close. 0.365. You see the problem? 0.365 is on the left side. 0.3649999. The fractional representation in binary for Python somehow went to the other side. So when you round off, what will it do? It will basically, try to get it closer to the right side, which in this case is 0.365 itself. Okay. Right? Because you know what I'm saying. So if you round off 0.364999 to 2, you get 0. To 3, you get 0.365. So Python can surprise you and it can, tell you, make you shout this, okay, once in a while, right? So these are some interesting things with floating point stuff. And, if you're surprised enough, let me continue. Use the decimal module. If you are a financial guy, if you want to go into finance, learn about the decimal module, spend your time with it. There are some libraries that use the decimal module. You can ask me later about it. And, understand your floating point numbers with Python, very important, so that actually, when you are compounding something using 0.365 or, something, you're not, eating away at your customer's interest, okay, that you need to pay at the end of the year. Correct. Okay. Now, scoping. Okay. So scoping with global variables is something that can throw you off. So basically, I'll just show you this, then I'll execute it. So this looks like there's a global variable here. And let me drag and drop my Emacs here. Can you see my Emacs? The editor, blue background. You can see, right? Hello? You can. Okay. Okay. I'm not hearing anybody saying anything. Okay, so this works. Okay, I thought I had the code for this. Yes, I have. So this works. So you see, there's a global variable here. Forget about the second function here. Okay, and then let us try and execute this addx function on the command line. So import scoping scope. No module font scope. Okay, sorry, in the wrong place. AddX, it takes a number. So yeah, 110. Okay, works fine. So AddX looks like this. You can see this code, right? Nobody's saying anything. You can, right?
Yes, sir.
Now I am doing a very innocuous statement after this. Okay, I am saying is it is equal x plus y, and I'm going to comment this out, and then I'm saying print z. Then I am at the below. I had commented this line out earlier. I'm just uncommenting it. I'm saying x equal x plus 1. Now I'm going to re-import by doing this, and then I'm going to invoke this. Now you got an exception. Okay, local variable x reference before assignment. Pretty interesting. Like, are you seeing things here? Wait, let me comment this back out, re-import it again. Hey, it's fine now. So something that happened after printing is affecting something before it. Okay, it looks like some Heisenberg bug here, huh? So anybody has an idea what's happening here? Somebody who has looked at this? So Python does something called local variable optimization. Back to my presentation. Okay, Python basically, when you don't have a clear reference for something, Python assumes it's a local variable. So earlier, what happened was that this is what happened. In the first case, we are not modifying x locally. Okay, so how is the code? Z is equal to x plus y, print z. X is not getting modified. X is only getting used on the right hand side. So Python is correctly assuming that x is global. Okay, and it will get it from the global scope because x equal to 100 here, and it works. In the second case, because of this line, x is getting modified locally. So Python assumes in this case wrongly that x is local. Okay, and the thing is that the assumption happens. Okay, and then it is trying to find a local x. It can't find a local x. Okay, so basically, if I change this to x equal to 10 here or something, it works. But in this case, x is global. Okay, and Python, surprisingly, is not smart enough to do either or automatically. It is not. You have to give it hints in this kind of cases. Okay, so maybe this comes as a surprise to you because it is not. So it tries to find it locally, it is not, so it gives an error. So in this case, you have to tell Python, hey, x is global. If you're going to do this, otherwise you don't need. Okay, so solution is that either don't do this. If you're going to do this, tell Python, hey, x is global, pick it from there. It works again. Got it? I comment this out again, same problem happens. This is called local variable optimization in Python. You will find it in many places. And, if you are not careful, okay. Closures. Same thing happens in closures in a different way. How many people have used a closure that is a Python with an inner function and with some code or variables in between? That's a closure. Have you used closures, Mr. Karthik?
Yes, sir.
You typically use closures when you're doing decorators in Python. Okay, you create an inner function, and you may not have any code in between. If you don't have any code in between the outside and inner function, it's not technically a closure. It is just a wrapped function. Okay. In this case, closure, the interesting thing is that the variable that is defined in the closure part, which is the space between the outer and the inner, is accessible to both. Okay. So I created a function closure, and the closure is very interesting because it defines a third scope. That area inside the closure is not in the global scope, it is not in the local scope with respect to the inner function. With respect to the inner function, it is in something known as the outer scope or the non-local scope. Okay, keep that word in mind because we'll see where that non-local thing is coming. So here I have a closure, z is equal to x into 2. The outer function is receiving x and it's printing z. The inner function is kind of dumb here, it's just printing z and returning z. Okay, and then let's see what happens. I believe I have defined that also here. Okay, Let me comment this out. So sorry guys, to avoid too much taking time, I have to do all these things. Okay, so let me import closure. Oh, okay, where am I? Import scope. Okay, so reload scope. Imp dot reload. Need to be fast here. Scope dot closure 10. 20, 20, 20. 3 20s are coming. Why? Outside print desired here, then return desired, and like I'm printing it there also basically. Okay, because that final print is coming from the value inside the Python prompt. Okay, got it? All fine. Now let me just do this. And re-import it. So what did I do? Just added a z equal x into 3. I'm modifying z inside the inner function scope. That's a change I did. And I'm going to re-invoke it. Same problem. Actually, same problem, local variable optimization. Because Python is seeing that z is modified locally, it is assuming there is a local z. Now, local where? Inside the inner function local. Okay, got it? It is looking for it, it can't find. Now, this is the thing. Python is like this blind man who, when you dangle, a piece of carrot or fruit locally in front of his eye, he will only look at that local. He will not find the carrots and the fruits outside in the kitchen. Okay. It's very interesting. Okay. If you are not seeing it, you'll be surprised. Now, here is the thing. Now, let me use global. You think that global works here? Okay, global. Import it. No. No. Why? Is it global or is it something else? It is not global. Global is here. Okay. Global means is it should have been outside here. Got it? So Python has introduced a new keyword. This has been there for one, non-local. Pretty interesting, huh? It is like, your friend, in Bangalore who is basically, he doesn't go abroad. Okay. He is also, I don't know what to say this. He's also not local. Maybe he keeps going to Kerala or something. He's not global, but he's not fully local. He's non-local. I'm just trying to make it fun. Okay. So non-local. Okay. The weirdest keyword I found in a language works. So what is happening is, it is telling the inner function, hey man, I am very sorry, don't try to optimize. It's not a local. So it's very clearly telling, don't local optimize this thing. It is non-local. Pick it up from the closure. Non-local is used for variables defined inside a closure scope. Got it? How many people have used non-local? Karthik, have you used non-local? No.
No,
So
sir.
here's the thing. Now, if I go and use this non-local anywhere else, it will tell that this keyword, what is non-local? I don't know. Okay, it'll act very weird. It will say that probably will not even compile, I think. Syntax error. That's so weird, right? It's acting as if it doesn't know what this keyword non-local is. So first time you're playing with non-local, you don't understand what it really is. Python will confuse the hell out of you. Okay, you will think that there is nothing called non-local. It has to be in the right place. Okay, so hopefully you learned something from that here. Cool. We need to rush. Enough with the local variable optimizations, non-locals, closures, dictionary keys. I believe you guys have seen this, but I'll just say d is equal to this. And I say d of 1 is equal to 2021. Then I say d of 1.0, which is obviously a different thing. It says 2021. Then I say d of 1. Sorry, very sorry. D of 1 is 2020. We have moved on to d of 1.0 is equal to 2021. Then what am I doing? Sorry, d of 1 equal to 2020. I'm in a hurry too much. D of 1.0 is equal to 2021. You expect two keys, but when you print d of 1, you see 2021. There is only one key. So 1 is number, okay, 1.0 is a float. They, in your mind, they are technically different things, but Python, same thing with a complex number. Why? Because in dictionaries, it is not the actual identity that matters, it's the equivalence that matters. So 1.0 is equal to 1. More correctly, it's a hash equivalence that matters. Hash of 1 and hash for 1.0 tends to be the same thing. So Python internally uses a hash function to basically, find the keys for these things. Okay. So that's the issue. It's not the equivalence that matters, it's a hash value equivalence. So basically means if you are defining a class which you need to keep as a whose instances as hash, as keys in a dictionary, you have to define this underscore hash, dunder hash. Okay, we call it a dunder hash. You need to do that, and you need to make sure that each of the instances gets a different dunder hash. Okay, when it returns, it has to be unique. Okay, so it's not the equivalence that matters, because in this case, they overrode the equivalence, on double dunder eq. It is returning true, so all instances are equal. Okay, so still the hash value will be different. So maybe I can show that here. Where did I do that? Scope dict keys.py. Okay, so my class, uh, increase buffer text size. Hopefully you can see this now. So I need to hurry a bit here. I have a lot of things to show. I think the time is not enough. Import dict keys. C1 is equal to dict keys dot my class. So it takes a value, which is what makes that hash unique. You can see it returns the same value. 10. What happened? Okay, sorry, extra bracket here. C2 is equal to dict keys my class 20. And C1 equal to C2, yes, it is equal, because I have overdone eq to return true all the time. However, if I create a dictionary, say d of C1 is equal to, let's put 10 itself. D of C2 is equal to 20, and then you will find it has 2 keys. Okay, so it's not 1. You got it? So it's not overriding. However, if I go and modify this hash to return 1.0 all the time, okay, fine. Now I'm going to reload it. Dot reload tick keys. Then I'm going to create these things pretty fast again. Okay, now actually C1 is equal to C2. Yes, no, I could have modified that to return false. Okay, so just to show that it's not the equivalence that matters. So let me reload it again. C1 equal to C2, false. Okay, however, if I now add the keys, they will actually be the same. Hash method should return an integer. Sorry. Yeah, forgot that. Again, wasting some time here. D is equal to this. D of C1 is equal to 10. D of C2 is equal to 10. Okay. So so basically in the case of classes, yeah, it has to be, I think it needs to be both, I believe. Yeah. So D of C1 is equal to 10, D of C2 is equal to 10, D, yes. Okay. Yeah. So, so now when you're creating a class, what you need to do, basically, you have to override the underscore hash, as well as make sure you override underscore equal also. And obviously, in this case, this is the false example. You should basically do a proper EQ. Okay, correct? So if your actual EQ will be something like, in this case, you can compare the X if self dot X equal to other dot X, return true, else return false, correct? So something like this. Got it? State checking. Hopefully you learned something from that also, because if you don't define the underscore hash in your class, you can't have a, so I didn't want to show that, we don't have time for that. Okay, you have to do that, otherwise it will give you an error telling that class can't be hashed. Where are we now? Yeah, so that is it. I'll probably skip these things because we need to go to something a little more interesting. How the sum function behaves with respect to containers and stuff. So how many of you use sum function to sum things in Python, basically? Sorry. So sum is what? Sum basically, what does sum do actually? Will this work? It doesn't work because sum actually takes an iterable. Okay, got it. So sum takes an iterable. So yeah, that works. Okay. However, some can have some pretty interesting side effects. So if you, for example, I can do this sum 10, 20, and I can do 30 outside. So that is undocumented. Okay. Well, that's not clear at least. Okay. If you do help of some, it may not be obvious because 30 is not an iterable. Okay, but it works. However, if you do the other way around, you think that, hey, wait, it is associative. You know, a plus b is equal to b plus a, at least you think like that. In this case, it's not okay. It can confuse you. Okay, right? Because if you do help of sum, the first thing it expects is an iterable, and then it is more flexible after that. Okay, so the first thing has to be an iterable. Okay, and it has some interesting properties. If you add, you can actually do these kind of weird things. It always returns the next one. Okay, and none always wins. Okay, you might think this will cause an exception, but no. Okay. Okay, but anything uniterable is a problem. Okay, so all these things, why it works is that all these things are iterables. Okay, a dictionary can be converted in iterable. Okay, tuple is an iterable. Okay, now
Anand, can I ask a question here?
yeah,
Is it
if you allow me to
intentionally?
go till 11 o'clock, yes.
No, this question is very specific to this. Okay, not specific. It is generic kind of thing.
Yeah.
Is it like in progress feature in Python, or is it intentionally left like that?
Actually, a lot of the things are because of the way it is implemented. Because what here happens is this. Okay, so if you do help of sum, I'll try to explain as quickly as I can. You can catch me after this. Return the sum of a start value plus an iterable of numbers. That is what the thing is. It is undocumented, but it is not clearly documented. So when I do this, what is happening is, I'm not saying start equal to, but I'm saying 30. So it is taking start equal to 30. You understand what is happening?
Okay.
Got it? That is the thing. So it looks like it is wrong, but see now what happens? Here is the thing with Python. A keyword argument can be substituted with a positional argument without specifying it. That is a problem. Python is so flexible. Though you don't say start equal to, it will take that as start equal to and it will do that. Okay? Understood? That is what is happening with all these cases. So if you do sum, this is taking that as and internally none is implemented inside sum as something to basically, what do you call? Like in this case, okay, so let us do this and see what happens. Then there is a problem. Okay. Now, since it is empty, Python is smart enough or over smart, whichever you want to call. There is none inside this. There is none outside this. A total is none.
Okay.
Got it?
Okay.
Okay.
Thanks.
And so the similar thing comes with filter. So you can actually use filter with none to see that a value is empty. Oh, okay. I'll show this to you later. I forgot the exact syntax. Okay. Yeah. So I'll probably tell you.
Sure. No worries.
So, and some can be used to flatten. There is a side effect of some. Some can be used to flatten, nested list to one level. Okay, you guys, that's a very interesting aspect. Someone smart enough, look at it and tell me how it is done later. Tell me how this happens later. Okay, if you're able to tell, you have a very good thinking. Your thinking of iteration in Python is top notch. If you're able to tell that, don't tell it now. So if I pass a first level nested list to Python like this, okay, so hopefully I got the syntax right here. Did I? No. So it will flatten it. Flatten it, it will kind of pick the inside. Okay, the inside list is coming out. Okay, you seen that? It's actually a nested list. Okay, list and then a list inside with another list inside. Now when I do that, the outer one is coming out. Okay, so talk about to me later. Okay. Enumeration you guys have used, but you probably haven't seen this. So I can do for I. Oh man, I wanted to show 10,000 things. Maybe Mr. Gajendra will allow me to continue. Uh, print I item. This you have seen, right? Sorry. Enumerate. Okay, sorry. So this you have seen. Everybody, I know, probably used enumerate can see. You can basically get an inside index into that number. In this case, let me make it a little more interesting by printing item square. So, yeah. So now index and the squares. Okay. Now, do you know that you can get an automatic dictionary out of enumerate? Dictionary can just appear. So let me show you that. Unfortunately, I don't have time to explain how this happens. Dictionary doesn't have an index. Dictionary is empty, but it just appears. Okay. So I'll probably use the same thing rather than Python, or maybe Python is interesting. Huh? This might sound completely magical, and it is. This is something which surprises me even now. Well, you got a dictionary out of thin air, okay? No exceptions. And this is beautiful. You can use that dictionary, and you got it in text right there with 0p, 1y, and all that. Okay, so I'll tell you why this happens later. Okay, so mutable references. I believe we can skip that. We just have enough time to show classes can change in Python, and hopefully the concurrency. Okay, I think I have a lot to say. Maybe if we have time in the afternoon, I can do a lightning talk or whatever. So we can change a class in Python. How many of you know that? You can change the class of an instance. If you know about this, then I'll skip it. Oh, we don't know. Okay. So let me show that because you can change a class. I'm calling this module as glass because it seems as fragile as a glass. Okay. So this is my class. Class A takes x and y, self.x equal to x, self.y equal to y. And f prints return self.x plus self.y. Class B takes only x and it assigns self.x, and inside the f it returns 2 into self.x, okay, twice of x. Okay, now let me import this glass module here and say a is equal to glass.a 10 20, a.f should return sum. Good. Okay, b is equal to glass.b 10, and it should return twice of that, b.f 20. Hopefully you're able to figure this out. Okay, 10 plus 20, 30, and 10 into 2, 20. Now, here is an interesting thing. Okay, now let me show you that I'm going to change the class of B. These classes are unrelated. This should not be allowed to happen. It worked. Now what happens? A.f. Okay, earlier A.f was giving you 10 plus
of two numbers.
20. Yeah, now
Oh.
A.f has changed to, I'm printing it so that you can see. It's actually printing B's class, okay? And it's returning the right thing. Now, what the heck is happening here? So what is A now? Type of A. It has changed in front of your eyes, okay? And now what does A's dict have? Okay, A's instance dict. Oh wait, it has both X. So it has become a Frankenstein's monster of A and B. Okay. it has B's. It has A's dictionary, but it has B's methods. Okay. It has A. The instance dictionary is x10 y20, which only A had. However, the method is now returning B's method. Okay. So it's a Frankenstein's monster of A and B. Now let us see what happens if you do the reverse. Okay, so I'm going to do all these things before A dot and B. Now, have you noticed that B is slightly poorer than A? A has got X and Y, B only has X, correct? Okay. Now, can someone predict if I do the reverse? What did I do earlier? A dot class equal to class dot B. Now, what if I do this? What will happen if I invoke B dot F? Okay, let me see if somebody can tell it in the next 10 seconds.
Sums
give
two
an
number
exception?
and then double set.
Huh?
It sums two numbers and then double.
No. What has happened is this. It is trying to invoke A's method. However, it is having B's dictionary, which doesn't have Y, it only has X. Got it? So here's the problem. When you do like this, the instance is having its data as original, but its method has changed. Method expects X and Y. However, it only has X. Okay, why? Because B dot dictionary is still the same. This is the instance dictionary. Okay, got it? So you have created a Frankenstein's monster, which has now no idea what it's doing. It's a Frankenstein's failed monster. At least the other guy had worked. Okay.
Monster.
Now here is the thing. This actually has practical applications. Now I'm not marketing my book. I'll be happy to share the code otherwise. In my book, I have created a design pattern called strategy, where strategy is basically where I think it is strategy. Okay, just I might be slightly rusty here, so I don't want to tell you guys the wrong thing. So give me a second to Google this. Sorry. Strategy pattern is where the class appears to change, or is it algorithm pattern? Just give me a second. Strategy pattern. And enabling and selecting an algorithm at runtime include, okay, selecting an algorithm at runtime. Wait, it's not a state pattern. Sorry, state pattern. There is a gang of a design pattern called state pattern, which is ideally suited for this kind of behavior of Python. I have a implementation in my software architecture with Python book. I'll be happy to show you outside, where this behavior is awesome because that is what we want to change the class, and make things work. However, don't do this. You can actually mess up your company's Python code by going and changing them. You can do this. Python allows you. You get an instance. Hey, I'm going to change the class underscore class to my class. Okay. Then somebody uses it and they'll be like, shit, man, everything is breaking. Tests are not running. Hey, I changed the class here. You have the power to do this. Okay. Python gives you a lot of power. No other language I know allows you to change your, your class. Okay. Like this. Anyway, don't misuse that power. So hopefully this made an impression on you. So I have all that here. Let me show you, wrap this up by showing Python and concurrency, because I want to show this. So give me maybe 5 extra minutes. You might think that Python, how many guys know about global interpreter lock? Oh, okay. That's interesting. So Python has this global interpreter lock, which is yielded around IO operations, but is blocked. So multiple threads don't work very well in Python for actually CPU bound tasks. Let me show you an example by using prime number filters. So we'll have to probably skip the rest of it. So here I have prime.py and I have a very simple function. So basically returns if a number is prime, okay? And it does by using that very simple C function, basically. And then I have a timer here. Then I have a simple function which finds the primes till a number n. So if I give 100, it will return all the prime numbers till 100. And this is serial, it's not concurrent. I have a concurrent version of it using concurrent futures thread tool executor, which uses threads. And you might think that the concurrency is better, but you will be surprised. So this uses threads to do that, and it uses all the CPU cores. I have 8 CPU cores in my laptop, so max work is equal to 8. The details of this thing, if you look at concurrent futures example, you can see how it works, or I'll be happy to explain later. I'll share all this code and all this thing later. But let's see how this works, okay? So sorry for being fast, but I want to wrap it up and take some questions. So what I'm going to do is that with prime dot timer, okay, there's a timer which actually prints how much time it takes. Prime is equal to, let me use the serial version, prime dot find primes and till 100. Okay, so it will tell me how much time it took. Time taken is just 0.002.2 milliseconds. Okay, very fast. Okay, so and you can actually verify that. I verified yesterday that this code is right. Should be actually having 25 primes. Okay, and let us increase it now, make it a little more, make it 10,000. Okay, so it has to work a bit more. Time taken, still 0.02 seconds. Okay, still pretty fast, and you should see around 168 primes, I think, inside 10,000. Oh, sorry, that is inside 1,000, 1229 primes. Okay. Now let's see how well this goes with a million. I know you might think it might be a problem, but believe me, serial is good. It doesn't take commission. Okay. Um, Probably around 15, 20 seconds, 7 seconds. Okay. And it actually will have around 32, some 78,000 primes are there in a million. Okay, 78,000 something. Now let us use the this thing. Okay, the concurrent version with prime dot timers. I'm going to edit the original one. Prime dot find primes concurrent. Now I'm not going to do this 100,000 million because it's going to hang my machine. I'll tell you why. Wait a second. How much did the first one take? 0.0002. Okay. zero point 0.2 millisecond. This is taking more. Okay. Concurrent version is taking more. Okay. Now let's try with 1000. Seems slightly better. Okay. But we didn't do the 1000 for the other one, I believe. For the non, we directly went to 10,000. So maybe with that, let's see how it is. 1000. 0.0007. Okay. Actually less. Now let us find what is happening with the concurrent for 10,000. 0.43. Now how much did the other guy take? I don't need to go back. I can just edit it right here. This is the only place. No, not even good. Okay, 0.43, 0.01. So the concurrent is always way slower than the serial. Okay. And here is one thing. If I am going to do the concurrent with a million, my machine is going to hang. I'm not going to do that because then there's entire, this connection will disconnect and all that. Okay. Now, can someone tell me what is happening here? Okay. Probably will take questions along with it. Okay. Why is the concurrent version, which apparently uses all the cores, so slow when compared to the serial version? Code is correct. Okay. So I know I know my concurrent code. I've been writing concurrent code for, many years. So this is correct. Does someone want to make a guess here? Karthik. Okay. So here's a problem. Python has something called global interpreter lock. Go Google it. It basically, it does not yield around bytecode or CPU intensive operations, effectively making sure that only one thread can execute in your entire CPU cores, in all your eight CPU cores at a given time. Basically means even though I'm using 8 threads, effectively only one is working at a given time. So it actually makes it slower. Okay. Way slower. Then there is also the overhead of creating the threads and running. So unless the thread execution is fast enough to compensate for all that, your concurrent code ends up becoming slower. So it's a surprise. Concurrent code can be slower in languages like this because it is not intended for the write operation. IO is fine. You write a web crawler with concurrent threads downloading stuff, it is going to work faster than the serial. Yes. But in this case, serial code works. Don't try to concurrentize this. In fact, if I change this to process tool executor, which uses processes, it's going to be even more slow. Okay. The only thing inside with process tool executor, it'll actually work. It's not going to hang my machine if I try for a million things. Okay. So that is the another surprise, not exactly surprise for people who know these issues of Python, but I thought it might be a surprise for you guys. I have a lot of things here after that. Some modules I wanted to say, which you guys may not have used. But we have run out of time. Okay. So I'll stop with this enough Python. Feel free to ask questions. Maybe I might be taking into somebody's time, but thank you. It has been nice. And explore Python. There are, Easter eggs like this. There are things that may surprise you, but overall Python makes you happy. Thank you. Okay, so I'm done in case I was too fast. So I believe my time was till 10:45, right? So I'm done.
No, the time is still 11, right?
Time is still 11. Okay.
You
That
still
is,
have 10 minutes.
I see. Okay.
7 minutes now.
Okay, guys. So let us see some interesting things with Python modules that you guys can do. Maybe you guys didn't know this. Python has this Python -m, which you can invoke some modules. calendar is very nice. If you use this, you actually see a calendar for the year. If you say some other year, it actually prints the calendar for that year. So if you want to know the calendar for the year that you were born, basically, now I'm giving off my age, I know. So, you can actually see this. Okay, this is very similar to the cal function, if you guys have seen this in Linux. Okay. But cal is not that friendly. So Python -m calendar is pretty friendly. Okay, it even has an HTML version, by the way. So you can actually say Python calendar.html calendar, and it actually, you need to give a year, I think. Okay, HTML calendar. Okay, I forgot this one, doesn't matter basically. So, there are a lot of these modules that allow you to do using Python EM basically. And there is something called a doc test module basically, through which you can put test inside your doc strings and invoke it without having to write a unit test. You can actually use this for small functions where you want to test inline. So I created a factorial function, and I put doc test inline. So you kind of mimic the Python interpreter prompt inside the documentation of the function. And then you can do it in two ways. Either you can put import doc test mode inside that, in which case if I do python factorial.py minus v, it will actually execute the test. It's like a unit test inside your code. Okay. And otherwise, what you can do is that you can say Python -m doc test. Where am I? Minus v module. You can do that also. Okay. So Python Python -m doc test minus v factorial dot py. Minus v is important. Otherwise, v I already put. Okay. Cool. So all the tests pass. It's a very smart way and very quick way to test. For example, I'll purposely fail this now. You'll see that it will fail. Try to use doc test in your small functions. It's not a replacement of unit test, but very quick if you are coding. If you have a habit to code on the interpreter prompt along with the along with your Python, and it's very easy to write some code like this on the interpreter prompt. Import factorial dot factorial. Obviously, factorial is a stupid example. Then you can just copy paste this into your into your doc string. Okay, and then remove the module prefix. Okay, that's it. So that is one. There is something called a file input module, which is pretty interesting. It can process a file or a list of files. A lot of people don't know. So I've been trying to show things that you guys maybe are not haven't heard about. Okay. So these modules are like kind of modules inside Python that you may not have heard about. So let me see if I have an example for that. So if you just invoke this thing, it'll act like a, it'll keep talking to you. It's like a Python file input. Hi. Okay, hi. It's like a, it's a kind of, you chat to yourself. Hello, how are you? Well, that's not very useful for it. But if you're really bored, you can do that. Or what you can do is that you can process a list of files. So, look at this function. This will actually, process any number of files you're passing and then convert all their lines to upper. Or you can do counts, or you can do NLP. Just 3 lines. Okay, so Python process files.py, and I'll give a number of files here. Factorial.py, I had scope.py before. Mutable.py, you'll find all of them getting printing one after the other with uppercase. So how many of you guys knew about this module? Probably not. Yes, that's what I thought. So that is with file input, pretty useful module. I use it for processing large number of files at one shot on the command line. I use it for a lot of my scripts. Very useful. HTTP. This is how I am presenting this, by the way. Okay. So Python -m HTTP dot server -p 8001 till, oh, there's no port. Okay. I think address already in use. Okay. So that's because I'm already running it. So you can get a help actually. Okay. It works like a command. So I can say --bind 0.0.0.0.0. Let me bind to port 8081. Okay. Localhost. Name of service not known. Okay, so cannot assign request address. What is happening? HTTP 127.0.0.1 8081 maybe. I haven't used it like that. Okay, so so what I'll do is I'll just stop what I'm running right now. That's the easiest thing. Yeah, this is what I'm running right now, and then show it to you guys again. So you can get a directory listing for this, and this is how I was presenting things to you. Okay, yeah. So let's go back to it. Okay, so that is HTTP server, pretty useful. I can kind of, if you want to quickly, I'll tell you where it is useful for this thing is. You want to show some files to someone on a call or something, and you don't know how basically to do that. Go to that directory, or do Python minus m HTTP dot server minus d. Give that directory. Let's say you want to show in your documents folder. Yes. Oh, okay. Sorry. Again, the address is in use. Okay. So you can actually do that. I'm just telling. Maybe you can click this again. Yes. And then go open it. Yes. It will appear very easy. Okay. Very small thing, but very useful. So I use it quite a bit, basically. Like as you can see, I was using it for this particular presentation. So yeah, that is what I was doing. Okay. So things that may surprise you. Hopefully you can you still see the presentation, or?
Yeah, we can see.
Okay, so cool. Inspect is very useful if you guys want to figure out what is happening with your code, with your you want to kind of get details into a function signature. So I have this funky function which I wrote before this, fns.py. Basically display time funky. If you want, I can show how this works. Import fns display time funky. It will kind of show the current time in an ASCII art format, basically 3D ASCII. Not load. Okay, 3D ASCII. Okay, so basically, it's actually showing the current time 11. Oh, thinking we're past probably. Okay, so maybe I'll stop. So you want to see the signature of this function, you can see inspect dot signature functions dot display time funky. That's very cool, right? Signature, it takes font, which is string, and it takes a filter whose value is metal. And it is very useful for figuring out and getting inspecting your your things, basically. It also has get arg spec, basically. It will even give you more information on that, so you can do inspect dot get arg spec. Okay, so get more details about this. Function has, what happened to this? Function has keyword only parameters or annotations. Okay, that's what happened. Okay, so that is the when you have annotations, it doesn't work. Get arg spec. So let me do that. Dot reload functions. I think now it should work. Arg spec, it is telling you, hey, it has got args font, and it has a arg called underscore filter. It doesn't have variable arguments. It doesn't have any keyword arguments. Basically, no, it actually has a keyword argument, which is filter, and I don't know, it's sort keywords equal to none. Okay, probably it's trying to say it doesn't use any keywords and defaults to metal. It gives you more information. Inspect can do a lot more. It can actually, if you, I have some examples where I figure out a stack. Okay, who was the caller of my function? You can do that in inspect in real time. Okay, who called me? Who was the third caller of my function? It means that somebody called another function, which function called another function that called me. You can figure out by using inspect and going back in the stack. So figure out, play around with inspect. I just wanted to show you the secrets module, which is kind of new in 3.3. I'm not sure how many people have used. Use that to generate secure passwords. Okay, so I generate my passwords not using the secrets module, but using the UID module, which is slightly older. But secrets module is also good, basically. So I have this example here. very shamelessly copied from Python standard library module, password.py, but generate your passwords like this. Don't use your birth date or anything. See? Okay. And there is another thing which I use, which is in that presentation, it didn't come very nicely. So maybe if I reduce the size, it didn't come. So I'll show you that function basically. That is there in my bash RC or module or something. So it's very simple trick using UID, and it's like this. So I actually generate my passwords, bank passwords, and all using UID module. Python -c import UID base 64 and UID bytes I decode in Latin. Okay, and it actually gives me very secure passwords. So what I do is that I run it like 10 times or something and take the 10th one and use it for my bank passwords. Okay, so don't try to guess my password. Okay. Last one, Python -web browser is very useful. You can actually do Google search using this if you want, which a geek like me does. -t HTTP. So does someone remember Google query format? Oh, I can't make it search. I forgot that. Python -m web browser will launch the web browser for you if it is not there, your default, and it will also load a tab for you if you want. And it is really useful. It even gives you help, I think. -h, yes. Open new window, open new tab. Cool, right? So I'm opening a tab, so I can basically go to BellPy like this. So is it bellpy.org? Bellpy.org, right?
Bellpy.in.
Bellpy.in. How many of you guys knew about that? Hopefully, no. So hopefully there are a lot of these things in Python -m modules. Actually, there are more. But for example, how many of you guys knew that you can clean up your JSON using this? Python -m JSON.tool. So maybe I'll take a few seconds and put a stupid JSON and clean it up. Okay, Emacs x.json, name first, Anand first /first. This is very useful. I'll tell you why. Because if your JSON has an error, it will point out that also. Okay, now this is not very readable. It's all in one line. Okay, but see how this guy's. Oh, see error. Okay, so I had some issue. Name first /first. What is the problem? Second. Oh wait, this is XML. What is wrong? Okay, this is what happens, when you've been programming for too long. Sorry. Okay. Oh my God, that is funny. Okay. So I had a good laugh with it. Hopefully this is JSON. So I am going to introduce an error there purposely. That comma should not be there.
Maybe you have written some code to process some XML file last time.
Yeah, so you see, it's giving you an error. So this is a very fast way to check your, JSONs. Okay, now still there is an error. That comma should not be there. I think this is too small for you guys. Okay, so let me increase the buffer. Now, if I remove this, yeah, it is fine. Okay, the only thing is that my JSON was already kind of nicely formatted, right? Because that's where I wrote it. Now let me mess it up. So you sometimes get this huge JSON dumps, from some databases and things, right? You can use JSON.tool to clean it up. Use this. If you don't take anything from this, use this. Very useful, okay? Okay, guys, more to say, but maybe another time. I think I've run over. Hopefully you learned at least one or two. Okay, and maybe somebody will remember this even with all the machine learning presentations. Okay, thanks.